today we will continue to finish session 3.1. And this Friday we will have our second quiz. Okay? So this Friday you will take a quiz on Blackboard. You have a whole day to start your quiz. Okay? And once you start it, you need to submit your answer within 30 minutes. Is that okay, everybody? Mm-hmm. And the quiz is about session 1.4 to 2.2. All right. And this is our course website. And then if you go down a little bit, do you see this link of questions? So if you click this link, you will see a Google document. So everybody can edit this Google documents. So this is for those of you, some of you like email me and ask me questions or come to my office hours. But I know some of you might have questions, but maybe you don't have time to ask me in person. Then you can print screen your questions and paste here. So when we have time in class, we can go over them together. Okay, everybody? So print screen, you know how to print screen? So if you use Windows system, then you can press three buttons, the Shift, the Windows, and S. So if I press Shift, Windows, and S, then you see I can print screen and paste here. So make it very easy. Right, everybody? So you can print screen and then paste the questions here. Okay, then I will check it like maybe weekly, and then we can go over the questions on your homework. So your homework, the Mobius generates like different problems. Sometimes maybe the problems are similar, but you have a different numbers to work with. Okay, so that's why if you ask me questions, it's better to print screen your questions. Because the Mobius to randomize the question. If you ask me, oh, how do I do number 3 in homework 1.5? I don't know what is number 3 because it randomizes the order. Okay, and also like you might have different questions than your classmates. So print screen your questions and paste here, then I will check it. But of course, if you want to know your answer quicker, email me, okay? Because I might not check this every day. So, because some of you asked me questions about 1.5 transformation, so I think it's better to go over some concepts. And I know in our class notes, we cover shift level, right? And we talk about refractions over the y-axis, refraction over the x-axis, and vertical stretch and compress, and then shift up and down. But we didn't mention the horizontal shift. But you do have some questions about horizontal shift. So I want to talk about it now. All right. So this is 1.5. Transformations. So we call shift left or right. Okay, shift left. Well, that's changing the x. So shift left, we will see x plus c, right? If you see x is changed to x plus c, then we know it's shifting to the left c unit. And if you see x is changing to x minus c, then we know it's going to shift to the right c units. Do you remember that, everybody? Okay. And how about shift up and down? Well, shift up, then we are changing the y, right? And you will see the y is changing to y plus c. And shift down, you will see the y is changing to y minus c. Is that okay, everybody? All right. How about refraction? So reflect over the y-axis. Think about it. Reflect over the y-axis. So it means, oh, this point get mapped to this point. Do you agree? Then, oh, you see, the y value is the same, but the x value, you flip it, right? So you put a minus sign in front of the x. So refraction over the y-axis, then we change the x to negative x. Is that okay, everybody? And then how about we flat over the x-axis? Well, x-axis right here. So this point get mapped to this point, right? You see you have the same x, but the y, you flip it down. So we're changing the y, and y become negative y. Is that okay, everybody? So that's refraction. And then stretch or compress. So vertical stretch. Then we will see the y change to c times y. Yes, everybody? So you will see the graph is more like skinny. So if you have a picture like this and stretch, you get the curve more skinny. Right, everybody? That's vertical stretch. And now let's talk about horizontal compress. Okay, if you see the x is changing to c times x, okay, then if c is greater than 1, then you actually have compress. Okay, for stretch, if c is greater than 1, you have stretch. If c is between 0 and 1, then you have compress. But for the horizontal, is the opposite. If c is bigger than 1, you have compress. If c is smaller than 1, bigger than 0, then you have stretch. Is that okay, everybody? So that's why your your x is changing to c times x. Okay. For example, this is absolute value of x. Okay. If we have y equals absolute value of 2 times x. Now what happened? Okay. We have 3 key points. We have 0, 0, 1, 1, and minus 1, 1, right? And now, look at this. Let's put the points. So it passed through 0, 0. And then when you plug in x is 1, do you see y equals absolute value of 2 times 1 is 2, right? So which is right here. And then you have a picture like this. Right? So when you multiply the x by c, if c is a number greater than 1, you actually will have horizontal compress. Okay? Yes, everybody? And do you also notice that this guy is also equal to 2 times absolute value of x? Yes? Right? So you can also think of this is a vertical stretch by a factor of 2. Okay, everybody? So if we multiply the y, so this is like a y. Okay, absolute value of x is a y. If we change the y to 2 times y, this is vertical stretch. So that's why, oh, you see, we keep the x the same, y stretch by, multiply by 2, and you get this picture. So this is, you can think of as vertical stretch or you can think of it as a horizontal compress. Okay, so tendons. Thank you. Okay, so now we learned all of them. What's the order of transformation? Well, the order first we shift left or right. Okay. Second, what we have is we flat over the y-axis. Now you can add horizontal compress. Okay, because we have learned it. And then the third one, we flat over the x-axis and vertical stretch. Is that okay? The third step is the same as before. And what is the last step? Shift up or down. So far, so good, everybody. Again, for those of you coming late, please check our recording for the first 10 minutes. And I want to repeat again. This Friday, we will have quiz 2. So don't forget to do your quiz 2, okay? We have total 8 quizzes, and we dropped the 2 lowest scores. Some of you already missed quiz 1. You don't want to miss quiz 2. Okay? Do you hear that? Quiz 2 this Friday. And how do you do it? On Blackboard. Okay. You have a whole day to start the quiz. And then once you start it, you need to submit within 30 minutes. Is that clear, everybody? Mm-hmm. And please upload like PDF. It's better to use your laptop to open it. Because I do like hear some of my students say if they use their phone, they couldn't see the quiz. Please use your laptop to open it. And then when you see the quiz questions, show your work on a piece of paper. After you finish, take a picture and then email it to yourself. And then you can use your laptop to copy those pictures to a Word document or Google documents and then save it as a PDF and then attach the PDF in Blackboard and submit the quiz. Is that okay, everybody? Mm-hmm. All right. So, or if you have like an internet issue that you're not able to submit it within 30 minutes, you can open a second attempt right away and attach the quiz results. Okay. So I set a limited attempt, but the limited attempt is not meaning you have a lot of time to do it. It's in case you run out of time in the first one. And the second one, you open the second attempt right away and submit it. Okay. All right. So that's the quiz. It's gonna be on Friday. All right. So this is similar to what we learned before, except this is the new thing. The horizontal compress. It's changing the x to c times x. Okay. Now, so let's do an example. So if we have okay, -4. So let's say g of x equals -4 and then 3x plus 2 minus 5. Okay, so if we have this, and then let's start with f of x and figure out all the transformations. So the first thing we check, do we have shift left or right? Mm-hmm. And you see is x plus 2, right? So the first step is change to x plus 2 and shift left or right? Plus 2. Left. So shift left 2 units. Is that okay, everybody? Oh, let me also put a minus sign here. Okay, then we can include all the possibilities. Next, you check. Do we have a minus sign in front of the x? If yes, then we have reflection over the y-axis. Yes, everybody? So that's why, yeah. So we have, so that's the first step, shift left or right. Second step, we have the minus sign in front of x. So this is we flat over the y-axis. Okay? And also, do you see the 3 is multiplying by x? Do you see that? That's why the next step, multiply the x by 3. Then we have f of negative 3x plus 2. This is horizontal compress. Horizontal compress. Do you see the 3? 3 is bigger than 1. So we have compressed. What does that mean? It means the y stay the same, but the x value, we divided by 3. Is that clear? For all the key points, the y value stay the same. The x value divided by 3. Okay? And then, okay, the third step. Do we have reflection over the x-axis? We check. Do we have minus sign in front of the whole thing? Yes. So we put the minus sign in front of that. And this is reflect over the x-axis. Is that okay, everybody? And then, what's next? Do we have vertical stretch? Yes. You see the 4? That's the vertical stretch. So negative 4, f of negative 3x plus 2. So this is vertical stretch. And how would the point change? Well, the x value will be the same. The y value multiplied by 4. Now, you see the difference? For compress, you are dividing by the 3. The vertical stretch, you're multiplying by the 4. So far, so good, everybody? Yes? Right? Okay. And then finally, we have negative 4 f of negative 3x plus 2 minus 5. What do we do? Shoot down 5 units. So thank you. And these are all the translations. So far, so good, everybody? Yes? Okay. And right. So I'm doing the recording. Feel free to, for those of you who missed the first couple minutes, feel free to watch the recording. And yes, right. Okay, now let's look at some example from your homework. Okay, this one. We have the following functions table, right? We have f and g and h. And we want to write g and h as transformations of f. Do you remember this problem? So my suggestion is plot those points. So plot those points. Okay. Look at the f. F say -2. -2. So -2. -2. Okay? And -1, -1. And 0, -3. Right? And 1, 1. And then 2, 2. So this is F. Okay? So if you want to make it more obvious, you can like connect them. Then you know this is F. Is that okay, everybody? Now let's draw the G. Let's use purple color. Okay, G, -3, -2. So -3, -2. That's the first point. And then -2, -1. -1, -3. 0, 1. 1, 2. Okay. We just connect the line to make it more obvious. Look at your G compared to your F. What do you say? Shift to the left. Okay? G is from F. Shift to the left. So shift to the left. What do you change? You change the X. Shift to the left, then you add. Yeah, add 1. Is that okay, everybody? You look at the graph and you figure out, oh, shift to the left. Add 1 to X. Okay, how about H? Do you like green? Negative 2, 2. Negative 2, 2. Negative 1, 3. And 0, 1. Okay. And 1, 5. So 1, 5. 1, 2, 3, 4, 5. And 2, 6. Okay, 2, 6. And connect them to make it more obvious. Okay, look at H. How do you change from the F? Shift out how many units? 4 units. Do you see that, everybody? Yes, shift up. So how will you change that? We plus 4. Okay? If you shift left or right, you're changing the X. Okay, then you do this thing inside the F. And then if you shift up or down, then you add a 4 outside of the X. Because you're changing the Y. Is that okay, everybody? So when you see a table, it's better to put those points. If you want to make it more obvious, you can connect those points. Then you can see better how would that change from the F. So far, so good? Okay. Some of you might not see this problem because Mobius randomly pick some problems. Okay. Now look at this. We follow the order. Our parent function is x cubed. Look at this new function. Do we have shift left or right? Do you see x plus or minus a number? No. Do you see refraction over the y-axis? Do you see a minus sign in front of x? No. Do we have horizontal compress? Do you see a number multiplied by x inside the function? Yes. And we have the 2, right? So we have the 2. That will give us horizontal compress. And then, do we have refraction over the x-axis or vertical stretch? No. But what happened with the minus 4? Shift down. Yes, so we have shift down. Okay, so we have horizontal compress and then shift down. So which is this part. So far so good, everybody? So you still go down the list. Okay. All right. Oh, so select the correct graph of the transformations. So, okay, how do we draw it? Remember the key points? So y equals x cubed. Yeah? It passed through 0, 0, 1, 1, and then 2. What's 2 cubed? 8. Yes? So we have this one and that one. Okay, and the key point is minus 1, minus 2, minus 8. Now we have horizontal compress. So y equals 2x cubed. And we have horizontal compress. So now what happened? Remember, we have the y value be the same. The x value divided by 2. Yes, everybody? So Yeah, maybe let me write it down. You're not familiar with that. So we have the x value divided by 2, but the y value is the same. Look at this point. 0, 0. We still get 0, 0. Right? Now look at this point. This point, the y value is the same, so the y value is 1. But then the x value divided by 2. So we get 1/2. Yeah, 1/2 and 1. So we're here. Yes, everybody? And how about this guy? 1. But then the y value stay the same. So this is 1/2, this is 1, and this is 8. So this is the horizontal compress. And you can put this point. This point is negative 1/2, negative 1. And this point is negative 1, negative 8. Is that okay, everybody? Okay. And then finally, 2x cubed minus 4, we shift down 4 units. Okay? So shift down 4 units. 0, 0 become negative 4. And then the 1/2 stay 1/2, but it becomes negative 3, right? Everybody? So 1/2 the negative 3, and then at 1 we get what? 4. So far so good, everybody? Okay. Yes. And now this what how this function is transformed from the original function. Well, we check. Do we have shift level right? Do we have shift level right? No. Do we have refraction of the y-axis? No. Do we have horizontal compress? Yes. Take the 2. So that's why when you okay. Oh, it have a minus sign. Okay, so then this minus sign is we flip over the x-axis, right? And we can have put the horizontal compress. Okay. But the preferred order will be horizontal compress first, and then we flip over the x-axis. So far, so good, everybody? Right. And yes. So write down a formula when this is reflect over the y-axis and horizontal compressed by a factor of 1/2. Okay, we flat over the y-axis. We flat over the y-axis. What do you get? Well, it's from here to here. So you're changing the x to minus x. Do you agree? Horizontal compress. You're changing the x to, well, in this case, 1/2 x. Yes. So therefore, we start with absolute value of x, and then we change the x to minus x. But do you see it's the same thing? Because the absolute value of x is an even function. It's symmetric with respect to the y-axis. That's why when you put it over, you still have the same function, same graph. Okay, and then we have next compress, horizontal compress. Then we get change the x to x over 2. So that's why you put your g as x over 2 as the value. So far, so good, everybody? So these are the exercise, the homework problems from 1.5. Any questions? Have you finished 1.5 yet? Okay, so I really, really hope that you can finish your homework weekly. So, yeah, because I don't want to set 38 different due dates. That's why I only set the 4 due dates. But I do hope you can finish your homework daily or weekly so that you can keep up and you can ask me questions. Right? I know a lot of you are freshmen. Trust me, the math in like in college at a much faster pace than the high school. So we don't want to study just right before the exam and get a good grade. No. For math in college, you need to practice a lot. You can try to see as many types of different problems as possible. Then you can do that 100%. Get a lot of practice on your homework, and your quiz, you learn from our mistakes. And well, I also give you the practice exams. So do those practice exams and grade it. Okay, learn from the mistakes. Okay, so try your best. If you have questions, feel free to email me or come to my office hours. And for those of you coming late, this is the website. Yeah, look at me. Do you see this link, questions? You click that and then you will see a Google Documents. So paste your questions here. And sometimes I will check it regularly. Okay? So you can paste your questions, your homework questions here. Or you can email me. All right. So we can go over them when we have time in class. Okay, everybody? Let's try our best. How many of you want to get A in this course? Raise your hand. You want to get A in this course? Yes? Yes? I have everybody? Okay, let's try our best to fight for A. Awesome. Okay, now let's go back to complex numbers. So last time we introduced complex numbers. We have, let me make sure it's recording. My microphone is on. Okay, good. We have the real parts and the imaginary parts. And last time we talked about how to add two complex numbers, right? We just treat the I as like the variable x, right? We combine the like terms. We combine the constant term and we combine the imaginary parts. All right, but how do we multiply complex numbers? Okay, so multiply complex numbers. So let's see. We use 4 times 2. So that's 4 times 2. And then plus 4 times negative 5i. Yes, everybody? Right? And then we have 3i times 2. Right? And then we have 3i times negative 5i. So far, so good. Anybody? Okay, let's simplify. What is 4 times 2? 8. 4 times negative 5? Negative 20i. 3 times 2? 6i. 3 times negative 5? I square. Yes, everybody? I square. So remember, I is that definition square root of -1. So I square will be -1. Oh, you see, this is actually positive 15, right? Because I square is -1. And it changed this negative to positive. Right? Yeah, we can combine the like terms. Everybody excited? Okay. So we combine the constant term. What's 8 plus 15? 23. And we combine the imaginary part. Negative 20 plus x is 14. Negative 14i. Okay. So this is what we get. Simplify, and we get this complex numbers. So far, so good, everybody? Yeah? Questions? All good? Okay. All right. So this is how we multiply complex numbers. Next, how do we divide complex numbers? So the complex conjugate is found by changing the sign of the imaginary imaginary parts of the complex number. So the real part of the number is left unchanged. In other words, the complex conjugate of a plus bi is a minus bi. Have you heard this before, complex conjugates? Okay, now you know. Complex conjugates, the real part is the same. But for the imaginary part, we change the sign of it. Okay, so a plus bi, complex conjugate is a minus bi. All right, now look at this problem. 2 plus 5i divided by 4 minus I. Okay? What we do what? We want to make the denominator to be real number. So what we do is we multiply the numerator and denominator by the complex conjugate of the denominator. What's the complex conjugate of this guy? 4 plus I. So 4 plus I. Okay? And because we're multiplying the same thing in the numerator and denominator, so we're not changing it. Right? It's still the same thing because the effect is like, oh, this guy over this guy, the cancel is like we're multiplying by 1. So we're not changing the quantity. Okay. So yeah, we multiply by the complex conjugate of the denominator. This is what we are doing. Okay. Now, what is special about it? Okay. Look at the numerator. We multiply it. 2 times 4. What's that? 2 times 4? 8. 2 times I? 2i. 5i times 4? 20i. 5i times I? 5i squared. Yes? 5i squared is actually negative 5. Yes, everybody? Nice. How about the denominator? Do you remember that formula? A plus b times a minus b is a squared minus b squared. Do you remember that? Yes? Right? If yes, raise your hand. Okay, those of you didn't raise your hand. Why do we get that? Well, we do a squared and then minus ab and then plus ab and then minus b squared because minus ab and plus ab cancel. That's why we have a squared minus b squared. Okay, it's not something difficult. It's just you multiply it out, you will see, oh, ab cancel. So we only have a squared minus b squared. Oh, but now, do you see this is different, right? A minus b times a plus b is then a squared. 4 squared minus b squared. So I squared. Yes. Oh, what is I squared? Negative 1. How nice. We have, look at the numerator. Combine the like terms. 8 minus 5 is 3. 2i plus 20i is 22i. Now look at your denominator. 4 squared. 16. And then minus negative 1 is plus 1. Oh, what's that? 17. So at the end, you want to express your complex number as the real parts. So 3 over 17 plus their imaginary parts. So 22 over 17i. So this is the standard form of complex number. So that's why at the end, make sure you separate the real part plus the imaginary parts. So far, so good, everybody? Yes? Okay. So, by the way, that's how to improve in this course. So you do homework, you review your notes, and then you ask me questions. If you're not available during my office hours, feel free to email me. I don't mind to like meet you virtually at night time, but I won't open my camera because I'm wearing pajamas. So, oh, you can schedule tutor. You know, we have free tutoring service in the Office of Student Success and Andover lower level. So they have free tutors, so you can schedule to meet the tutor weekly. And so we try our best to improve. Okay, and to be successful in this course. Okay, example 5. So we let f of x be the following. We evaluate f of 3 plus I. Okay. So f of 3 plus I, remember, this thing is whenever we see x in the expression, we replace x by 3 plus I. Therefore, oh, do you see x here? X squared. So we have 3 plus I squared, right? And then minus 5 times x, 3 plus I. And then plus 2. Okay? Whenever we see x, replace x by 3 plus I. Okay? All right. What is 3 plus I squared? You can, if you remember the formula, a plus b squared is a squared plus 2ab plus b squared. Do you remember this formula? Yes? Okay. Then this is like our a. This is like our b, right? So then that is a squared. So 3 squared plus 2a. A is 3. B is I plus b squared. I squared. Yes, everybody? Oh, and then, oh, distribute. What's this? Negative 15. And then, negative 59? 5i, yes. And plus 2. Okay, what is I squared? Negative 1. Okay. So what is 3 squared? 9. Okay. Let's look at the constant term. 9 minus 1 is 8. 8 minus 15. Negative 7 plus 2. Negative 5. Is that okay, everybody? So our constant term is negative 5. And then the I terms. 2 times 3. 6i minus 5i. I. Yes. I. So this is the okay, so you simplify a complex number, so you have the real parts plus the imaginary parts. Okay? All right. Let's continue. How about this? Oh, so we have f of 4i minus 1 equals 2 plus 4i minus 1. Yes? And then denominator. Yes. So whenever you see x, replace x by 4i minus 1. Right, everybody? Okay. Can we simplify? What's the numerator? What's 2 minus 1? 1. Oh, 1 plus 4i. How about the denominator? 4i minus 4. Yes, everybody? Okay. So here, what do you think? What we should do? And we can solve this. We want to multiply by the conjugate of the denominator. But do you see 4i minus 4 has a common factor 4? So it might be better to factor out the 4 first. Okay. Let's compare. So if we don't factor out the 4, well then you are multiplying by the conjugate. So 4i plus 4, 4i plus 4, right? Which is a big number. But if you factor out the 4, and then you get what? I minus 1. So you just want to get rid of the I minus 1. So you're multiplying by I plus 1 and I minus 1. So which way do you think is easier? This or that? The second one. Because your calculation will be smaller numbers. Is that okay, everybody? So that's why my suggestion is simplify. If there is some common factor, factor that out. And we want to get rid of the complex number in the denominator. That's why we multiply by its conjugate. Oops. Do you see my mistake? Yeah, this should be plus. Right. Okay, very good. Alright, so let's continue. So we have 4 down here. And numerator. You see? 1 times I is I. 1 times 1 is 1. And then 4i times I is 4i squared. But 4i squared is negative 4. Yes. And then we have plus what? 4i. That's the numerator. So far, so good. And denominator. Yes. A minus b times a plus b is a squared minus b squared. Is that okay, everybody? A squared minus b squared. All right. So, what is I squared? Negative 1. Okay. Now we continue. We get, do you see the denominator? What's minus 1 minus 1? Negative 2. Negative 2 times 4. Negative 8. So the denominator is negative 8. Look at the numerator. 1 minus 4 is what? 1 minus 4 is negative 3. How many I? 5i. Yes. And separate them. Separate the real parts. And what is the real part? 3/8. And then, what's the imaginary part? Plus or minus? Minus, right? 5/8i. Okay. So that finished the part. And so that's why algebra is very important because you cannot do this problem using a calculator. Yes. So you want to play with all the different squares, complete squares, all those formula. Okay. Any questions so far? All right, next. Simplifying powers of I. We know I to the 1 is I squared is -1. We know that, right? I cubed. Well, I cubed is I squared times I. But I squared is -1. So -1 times I is -I. Okay? I to the 4th. I to the 4th is I cubed times I. So that's 4. Therefore, you have I cubed is minus I times I. Do you see is minus I squared? And I squared is -1. So minus minus 1 becomes 1. So I to the 4th is 1. And then I to the 5th is then I to the 4th times I, which is I. So it repeats. Okay, can you see the cycle? So I to the 4th, we get back to 1. And then I to the 5 is I to the 6 is -1. I to the 7 is -I. Right, everybody? So what is I to the 35? Any guess? I? Okay, so how do we think? 35. And we know the cycle is 4, right? Every 4 of them we repeat. So 35 divided by 4. And what is that? 8, right? 8 times 4 is 32. And then you use 35 minus 32 is 3. So 35 is 4 times 8 plus 3. Do you agree? Mm-hmm. Okay, now I to the 35 is I to the 40. So 4 times 8 plus 3. Okay, all these lives on the exponents, and then we call the exponent rule. X to the a times x to the b is x to the a plus b. X to the a to the power of b is x to the a times b, right? So, now because this is plus, so this is I to the 4 times a times I cube. Do you agree? Yes, because we add the exponents, we can split them. And then these guys multiply each other, right? And then, do you see 4 to the 8? So I can rewrite it as, let's do I to the 4 to the power of 8 times I cube. Right, everybody? Now, what's I to the 4? 1. 1 to the 8 is 1. Oh, this is just I cube. And what's I cube? -I. Okay? Now, if you see any other number, you do the same thing. Okay? Divide it by 4. Figure out what's the remainder. Then it equals to I to that remainder. So far, so good? Everybody? Okay. Awesome. So, keep going. We're going to increase difficulties. Evaluate and simplify. Okay. So, evaluate and simplify. Okay. So, this one, we have 2 fractions. So, first of all, we want to simplify them. Okay. Look at the first fraction. So 3 plus 2i over 1 minus 2i. Okay, can you tell me what do we multiply by? Yes. Yes, everybody? We multiply by the conjugate of the denominator. And then, okay, minus the second fraction. Can you tell me what do we multiply by? Yeah, 3 minus I. Yes, everybody? Okay, continue. So, because this is a harder problem, then we write less. Okay, so 3 times 1, what's that? 3. Okay, 3 times 1 is 3. 3 times 2i, 6i. Right, everybody? 2i times 1, 2i. 2i times 2i, 4i squared, which is, what's 4i squared? Negative 4. So far, so good? Yes. Okay, how about the denominator? So, a minus b times a plus b is a squared. What's a squared? 1 minus b squared. What's b squared? 4i squared. Yes, everybody? So this is the first fraction. And what's I squared again? Negative 1. Oh, what's this thing? 1 minus 4 times negative 1 is what? 1 plus 4, which is 5. Right, everybody? So this is 5. Okay. We keep going. Alright. Okay. 2 times 3. 6. 2 times minus I. Negative 2i. Negative 3i times 3. Negative 9i. Negative 3i times negative I. Negative or positive? Positive 3i squared. Very good. And 3i squared is what? Negative 3. Okay, how about the denominator? So, what do we get? 9. So, how do we say? This is like, okay, again, a plus b times a minus b is a squared. What's a squared? 9 minus b squared. What's b squared? I squared, which is negative 1. So 9 minus negative 1 is 10. Yes, everybody? Right? Okay. And then we got, okay, what is the numerator? 3 minus 4 is, what's that? Negative 1. How many I? 8i. Denominator is 5, right? Minus, what's the constant? 3. And minus 11i over 10. What's the common denominator? 10. So we multiply by 2. Okay? So 2 times negative 1 is negative 2. And 2 times 8, 69. Okay. What happened with the minus? It gives us negative 3 and then plus 11i. Be careful. This is a common mistake. Okay, sometimes because you don't see the parentheses here, but it's actually there is a parentheses. This is minus of the whole thing. So minus minus becomes plus. This is a common mistake. Can everybody see that? Mm-hmm. Okay, what's the constant term? -5, right? And how many I? 27, right? Over 10. Let's split them. What is 5 over 10? 1/2, yes. And then 27 over 10, I. So far, so good, everybody? My suggestions, when you do your homework, do not use calculator. You can use your calculator to check your work, but first finish it without a calculator, and then use a calculator. Okay? Right. So it's good to practice our algebra. Okay, so we still have 6 minutes. We can still do one more problem. Yeah? Let's see which one. Okay, let's do an easier one. Let's do this one. This one is easier. Okay, so we know I to the 4 is 1, right? If you see the I power is in the denominator, you try to make it to be a multiple of 4. So, let's see. Okay. Let's do, what do we multiply the power of I so that I have my denominator is I to the multiple of 4 power. So 21, what is the next multiple of 4? Greater than 21. 24. Do you agree? Yes? So what do you want to multiply here? How do you get 24? You multiply by thirds. Yes, everybody? So we multiply by I to the third. Yes? And then minus 5I to the 11. What's 11? Think about 11 is what? So 11 divided by 4, what do I put here? What multiplied by 4? 2. And we get 8, right? The remainder is 3. So this is 4 times 2 plus 3. Yes. Now you see 3I cubed, but the denominator is I to the 24. Yes. And you know I to the 24 is 1. Okay, any multiple of 4, the power is 1. So, and then this is what? I cube. Can we do that last time? We know. This is like I to the 4 to the 2 and times I cube, and then this part would be 1. So that's why you only left with I cube. Can we do that? Okay. Ooh, now you see 3I cube minus 5I cube is what? Negative 2I cube. And what is I cube? Negative I. Ooh, so what's that? 2I. Yes. That's the final answer for this problem. So far, so good, everybody. Yeah, please practice this at home, and then Friday we will start this problem. Okay, so please practice this at home. Have a good day. Don't forget to do your quiz on Friday.